The last size of KMAP we need to look at is going to be a 5-variable KMAP. So with a 5-variable KMAP, we will be looking at an expression that is, for example, f of a, b, c, d, and e. Now, when we go about doing these 5-variable K-maps, you're going to need to try to determine for yourself what is going to be the best orientation. So the best orientation is going to be, what's in your mind looks to make the most sense to you. So there are two options that you have. These options are kind of similar when we talked about like a 3-variable K-map. Do I set it up in a horizontal orientation or a vertical orientation? Something similar. The two options are you can do two K-maps together. So in that case, we do two 4-variable K-maps. And when we do these 4-variable K-maps, we're going to place two side by side so we can see how connections are going to be made. The way we're going to label these, it's very important that you kind of keep with the same orientation. We'll label the most significant bit as each different K-map. So we'll say A is a 0 for the first K-map, A is a 1 for the second K-map. Then we'll do B, C, D, E as what's on the 4-variable K-maps, and you assign those the exact same way. Now, what's going to end up happening is you're going to have to keep track of what the bits are, because you'll need to know what the midterms that you're going to be connecting. So for example, let me write this in red. This is 5 bits. This box here is 0, 0, 0, 0. 0, 0, 0, 0, 1. 0, 0, 0, 1, 1. 0, 0, 0, 1, 0. So it gives you an idea of what it is the numbers are. When we're looking at the midterm itself, that's number 0, number 1, number 2, number 3, 4, 5, 6, 7. So that A equals 0 ends up having the same numbers as a 4-variable K-map. When we move to A equal to 1, they're going to start at 16 and go to 31. So it goes 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. So those are all the values. You can put in a little m, you can put in a big M. That's where they're going to be associated with. The other option you could have is you can do one K-map. And a lot of this is going to make a difference on, how you're able to spatially see values. Some people find 2 K-maps easier to do because it's less cluttered. The 1 K-map, what we're going to do is we're going to divide each box together. And this diagonal box is going to separate out the 2 K-maps that we previously saw side by side. So I would say A and 1 would be above the line, 0 would be below the line. We do B, C, D, E, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And the way you can kind of view this is think of everything above the line is like the blue K-map. Where I'm going to go back and I'm going to mark up the 2 side-by-sides K-maps. So this above the line, that's this one here. It's everything in blue for that first K-map. Well, everything below the line, that's orange. And that would be the A is equal to 0 K-map. All right, so we're seeing 2 K-maps being placed right on top of each other. All right, so going back, that's this whole K-map on the left. That's everything below that line. The way you can kind of view this is it's kind of like you had two K-maps, on top of each other. The numbering is important again. It stays the same. So 0, 1, 2, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that's the numbering for the midterms and the max terms. Then it becomes on the other side 16, 17, 18, 19, 20, 21, 22, 23. And we fill out all of those items. So that way we have all 32 locations. Now, when we come to solve a 5-variable KMAP, again, we look at how many items we group, number of variables. So if we group one item, that one item is going to have 5 variables. It'll be A, B, C, D, E. We do a group of 2 items, well, that's going to go to 4 variables. You drop one of these. Here, I'm going to start dropping, E. Then you can group 4 items together. You group 4 items together, you lose another variable. You get down to 3, so it's A, B, C. Next size is you can group 8 items together. Remember, it's in powers of 2. That's going to go down to 2 variables. That's like A, B. And then last, you can group 16 items together. That would get you down to 1 variable, just an A. So what do these groupings kind of look like? All right, let's do the 2 K-maps next to each other, and I'll show you how we do some groupings. And then I'll show you what that looks like on a single K-map in the next example. All right, so let's say here is A is equal to 0, A is equal to 1. I'm just going to throw in a couple of 1s here. It could be don't cares as well. I'm just going to keep everything simple with just 1s. All right, so let's throw in these 2 1s here. Well, those 2 1s, you can view them as, well, they're part of a single K-map. I can group them like that. That's a group of 2. Okay, what would that kind of look like? Well, we're on the A equals 0 K-map, so A bar is in the term. B is staying the same, so that's B bar. D and E stay the same, so that's D bar, E bar. So we can kind of group items in that format. Other things we can do is maybe I have a group, and when I group these, I say, okay, I got a group of 4 here, and that overlaps with this group here, because if we were to take it, like I said before, you look at having 2 K-maps on top of each other, you can connect down, but then these 2 become connected. And that forms a group of 8. So we try to figure out what the term is. We see that A is changing. It's using both A0 and A1. So A is out of the term. We use every single value of BC. So BC is out of the term. So we end up with D E bar. We can have something like just 2 1s in. But then again, that's a grouping that we can make. Okay, what are the terms that are being used? Well, A is changing, A is out. BC stayed the same, so that's BC. DE stayed the same, D bar E. So we can make those connections when it comes to having 2 K-maps right next to each other. Okay, so what does this look like similarly if we were to have done just one K-map? So if we do one K-map, let's set it up. A big 4-variable K-map, and then we divide lines splitting each of these bars. All right, so that looks good. What we're going to do is, again, you can have stuff on two items lined up. When you have two items lined up, you're only using the top section. So on the top section, we group those two together. Well, that was A was a 1, so that's A. Then we have B stayed the same, so that's B bar. Then we have D bar, E bar. So we can have those items be used. So you can look on the top items. Maybe you have two items that share one box. Well, one big box, you can group a big box together. That's kind of form up a solid 1. Well, what would that be is we're using A, both values. So A drops. We have B, C, D bar, and E bar. And then you can look at the last one that we did. Well, if every little box divided up forms of one big box, like what was in the green, well, then I could take that and I could say, okay, I can group all of those together. We use every value of A, we use every value of B, C, so we end up with D, E bar. So that's how we go about, solving a 5-variable K-map. When you get to 5-variable K-maps, it's going to be very important that how do we select what's the best? You're going to have to start by looking at what only has one option. Start with circling the stuff that has one option, then look for the largest connection. All right, so that's how we can go about doing a 5-variable K-map.